December 1st, 2025. Guys, we've almost made it through another year. Won't be long. We'll be in 2026 and all the confusion from the midterms. That'll be lovely, won't it? But remember, they're very important this year. Now, this morning, it is 44 degrees. It was about 40 when the sun came up, and it's overcast and damp feeling. Now, I think we're going to get some sunshine tomorrow here, then we may go back into this pattern. But it's bearable now at 44 degrees, of course. Anyway, we've had an X1.9 solar flare this morning. You can see it right here on the top left limb of the sun. And right here is the chart. And you can see this is the X line, so we're at X1.95, but almost a 2 practically. But guys, if this had been directly Earth-facing, it probably would have been listed stronger. But it gives us the radio blackouts that we see in the upper atmosphere of our planet. But one of the things that was surprising is we have two very powerful sunspots, and they're located below this area. They weren't expecting an X flare from this spot, but that tells you that we're going back into an active period. And for you guys that you feel these flares, that's one of the reasons I'm doing this one. Of course, radio blackout too. And another reason, but this area down here, we're going to look at it closer because it is two sunspots. Each one is magnetically configured with opposite polarities. In other words, the arcing mechanisms are there for a lot of strong flares because all three of these are just coming around the left side of the sun. It's about a 27-day rotation period, but it looks like we're in for about 2 weeks of very active solar activity. And again, the flare came from sunspot AR 4274. It says the source of a number of X flares back in early November is now turning back into view from off the northeast limb. It just produced an X1.9 solar flare with a R3 radio blackout, 249 UTC today. The event appears to be eruptive, meaning a coronal mass ejection will be associated. Now, from that side of the sun, more than likely, it will not be directly Earth-facing. As it rotates around to the right, that will change. It says this event was responsible for an energetic coronal mass ejection that is headed mostly away from Earth. Should it have been Earth-directed, we would have been looking forward to likely another severe geomagnetic storm. The region will continue to rotate into a better position over the next several days. That's what I'm talking about, guys. It's going to be coming around Earth-facing because the images we're looking at are from satellites between the Earth and the Sun that gives us that Earth-facing perspective. Now, there's another satellite that gives us the same perspective. It's the LASCO C3 and C2 cameras. This is the wider image, the blue one that gives us millions of miles of view space here. And this is LASCO C3. Now, right here on December 1st, notice as it goes back to the 27th, you can tell this area is coming around the sun. Watch this. On December 1st, again, timestamp, you'll see that very powerful coronal mass ejection this morning. 30th into the 1st. Right there. And that's a good thing that one was not directly Earth-facing because we definitely had a geomagnetic storm involved. Now, something while we're looking at this image, we've been watching Atlas, and from an Earth-facing perspective, it would be up in this area. Now, something unique is that Venus, Mercury, Mars, and Jupiter are all on this right side of the sun. And just pointing that out because of magnetic activity between objects and alignments can do a lot inside this electric universe. The Space Weather's got a little more information about this large sunspot group that's coming around. Look at these images right here. It says giant sunspot alert. Sunspot complex is what they're calling it now. 4294-96 is so big it won't fit in a single photo. I had to combine 2 panels to capture the massive complex. This is from Amrit Shicharan, who sends this mosaic from Trinidad. This is one of the biggest sunspot groups of the past 10 years. From end to end, it measures 180,000 kilometers, and at least 5 of the dark cores are individually larger than Earth. These dimensions make it an easy target for safely filtered backyard and telescopes. If you don't have a solar filter, try the simple projection technique that you've seen it with eclipses and things like that, guys. But I've seen people film these and actually make a lens over their 35 millimeter from a welding helmet glass so that you could get this type of imaging. But again, they're mentioning here, by the way, that Mars rover, looking through the dust of Mars, spotted these sunspots on the backside of the sun a few days ago. But these are very large, and they are, again, southern hemisphere events. We're going to have to pay attention. Guys, and I've always seen CERN take advantage of this solar activity for years and years. Here's beam 1 and beam 2. This is live. Notice your timestamp up here, 1716. That's universal time because CERN is on the Franco-Swiss border. This is very high energy. You're looking at windage and elevation. This is the left tube. Beam 2 is over on this side. What they're doing, you've got a 17-mile loop underground. And with the most high energy machine, largest machine ever developed that we know of inside the solar system. And they're firing these beams around so fast to get them to collide. But in order for that to happen, to get the most power from the collision, is they have to really get your windage here. Your elevation here, windage here, the same. And they've been bouncing back and forth. You can see that. But what's happening, if you remember, I said CERN's magnetic field is 100,000 times more powerful than Earth's magnetic field. Because Earth is a natural field. It's the magnetic field is our shield, and it's delicately balanced by our Father's hand. But CERN is not. It's a man-made machine. And because it's so large, it's like it's controlling our shields. Now, when it usually is down by this time of the year. The last several years, you get into November, and they're shut down for a few months through spring. But right now, they're running hot. Now, again, this is live. So what you're looking at in the black line, these are power peaks. And that peak comes from the combination of the blue line and the red line, beam 1 and beam 2. So when they're combining, as they were in this chart right here, they had them dead on in the windage and elevation. This power peaked up here, and this is above 6.5 gigaelectron volts. And that was what it had been running for years. Now we're around 6.8, so we're getting stronger by really each season, because this season, before they started, I mentioned they had put new shielding in that would allow them to run hotter without the heat problems that shuts down this big cylinder. That 17-mile loop, inside of it, that has to be around 2 degrees Celsius, and that's the temperature of outer space. Are all of these high magnets and high energy running through there would overheat everything. So the cryogenics are extremely important. And I think this year, before they kicked in, we mentioned it. I think I showed an article about the improved pieces inside the CERN machine that would allow this increased power and to run longer. So, guys, we've heard for years the different theories about what CERN is doing, from opening portals to let things in or out. And again, that's speculation. What is not speculated is the fact that it is definitely messing with the shields of our planet. Now, I've always said, was that an unintended side effect? They never have admitted it. They never talk about it. NASA will not talk about it. Nobody will talk about it. It's like CERN is the world's machine. Gets all the funding it needs. Everything's kept down quiet. It's all underground, basically, except some of those top sections that you see that looks like a giant Tesla coil. Now, quickly before I do that, I did want to go here and look at the ion physics from the cryogenic page right here. These are sections. Section 12, you can see the numbers all through here, CS, IR4, and all of that, right? And those are sections within inside that 17-mile collision loop. If one of these go red, everything stops. And what we're seeing with the pulsing from the first page I showed you was the fact that the windage and elevation varies off, and you see the power drop, not necessarily a power loss from the new methods and the new shielding inside this cryogenic unit. Notice down here, temperature in Kelvin, temperature of outer space, and right there, I'm sure this was red, you see that one line, and what happens, guys, each one of these sections has a different colored line, just like spaghetti models on a hurricane map. But when you see this one red line, all of these are in sync. Now, this video I did November 15th, 2018, 7 years ago, guys. And what it's showing you is the Earth and the Earth's magnetopause, and the Earth is represented in the center circle. White half of it is the sun-facing side. This is the night-facing. And what you're dealing with right here is this band of satellites that rotate around the Earth and give us this information. They're listed over here, 14, 13, and comms in Korea. Some of that's changed. But this model was taken down, guys, because, now guys, this is from November 15th, 2018. It's a video that I did. This is just a still shot, but I'm going to play just a little bit of it. I've got, again, it goes back 7 years now. And just like with the earthquake situation, when I first saw that the X flares, when they hit Tokyo that afternoon, and we had the Fukushima event, that's when I started relating the solar flares to earthquakes and the pressure on our tectonic plates. No one but a few listened. None of the scientists would agree. They would not. It took a few years. Now it's mainstream. But that's how, when you pay attention, that's how it works. Same thing happened here. This is, again, November 15th, 7 years ago. What you're looking at is a model that's built via satellite information. You see this dotted line right here? It lists satellites, like your X there is 14, and then GOS 13 is a diamond. And they had a few other ones listed here. The triangle, which is not showing, was that comes out of South Korea. But again, 7 years ago. Now, in the center of this, the circle is half of it's white, half of it's black. That represents our Earth. And all of this information is coming from these satellites and other satellites. And the white side of the Earth is the sun-facing side. Now, the magnetosphere, or magnetopause, excuse me, part of the whole system is this line. This is an average time. At this, and what I was doing was, notice it was in universal time at the top. I was matching the time that CERN was peaking its power, just like on the graphs I was showing you when the red and blue line would combine. The black line would level out very high. That's the power line. And so I would time it with this model showing our shields, and it was exactly as soon as it hit, as soon as they cranked up CERN, that 100,000 times more powerful magnetic shield collapses ours. That's why they took this model down. And I had to go back this far. What I'm going to do, though, guys, is after this video, I'm almost through with it, is I'm going to go back and look at that video and just put it all up, because it has so much information, how it technically ties into our Earth shields via the magnetic lines of force, both underground and coming from space. And remember, I have this model timed with what was going on with the CERN models, and I would correlate the times and look at what was happening. As we play this forward, again, the shield's in pretty good shape here. You'll start to see collapsing here and at the top. I'm not playing it, I'm stepping it forward. See that? That allows a lot of radiation. And guys, this was just the first model that I found. I probably did 50 videos during that time about what CERN was doing to our shields. And you look right there. Again, these are just large openings for events, radiation events that penetrate not only the satellite band, I've seen them being way past that, but it allows openings into our atmosphere and to penetrate to the ground. But what you're seeing in the pulsing here is, if back then they did not have that new shielding that they have now. I said they could run further. or run hotter longer because of that new shields they installed before this year's run. Back then they didn't have it, so when they'd start really peaking in power, you would see a lot of downtime in between runs because certain sections of that cryogenics page would go red instead of all being green. But even here, these contortions. But this is the first one of the videos I found. I've seen this thing really jagged. But those are the effects. And so when you're in the satellite band, going down further, anybody, space shuttle people, airline, people that are exposed a long time, do a lot of traveling, so on and so forth, you're exposed. But again, the heat factor, things like that change when you let that much radiation that much closer. And we're talking about a very long way. When you see these things bend in that far, you're talking about a lot closer to the Earth than it should be. Again, watch the next video. I'm going to go through this, that section, this particular section, which by the way is high latitude ionospheric currents, guys. You got field aligned currents coming in and going back out. Now notice it's in the upper part of the northern hemisphere, so is CERN. And the yellow lines are the Peterson currents and Hall currents that are underground, so is CERN underground. And they both affect our shields that way, and I think they draw energy that way. Anyway, watch for the next coming video, guys. And again, we're moving into an active couple of weeks from our sun. So heads up, be safe.